Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 10, Lesson number 7 on multiplying and dividing rational expressions. Now, just like in our last lesson where we looked to simplify rational expressions, here what we're going to do is we're going to start by reviewing how you multiply two numerical fractions together, and then we'll take that and extend it to fractions that have variables in them. So let's jump right into it. All right. Exercise 1, letter A, says simplify each of the following rational expressions by factoring completely. For the numerical fraction, make sure to prime factor all numerators and denominators. Now, before we do exactly what the problem asks us to do, let me review just basically how you would have done this problem back in middle school. Now, I can't say for certain how your middle school teacher or even your elementary teacher would have had you do this, but lots of teachers will say what's called cross-canceling. So they'll look at the 6 and the 3 and they'll go, hey, 3 goes into 6 2 times. Then they'll look at the 8 and the 10 and they'll go, oh, I can bring a 2 into the 8 and I can bring a 2 into the 10. And then they just have the students multiply across. 2 times 5 is 10, 4 times 1 is 4. Oh, but that still needs to be reduced, so I'll take a 2 out of that, and I'll get 5 halves. Something like that. All right. Now, what I'm going to do is show you why that works with numerical fractions. So think about the 6/8 for a second, right? 6 is equal to 2 times 3, right? So all I'm going to do is factor this fraction. 8 is equal to 2 times 2 times 2. Remember prime factoring? That's that guy. Times, now 10 is equal to 2 times 5, and well, 3 is just equal to 3. It's prime, you can't factor it. So that's been prime factored. Now keep in mind that when you multiply fractions together, you just multiply their numerators. And you multiply their denominators. But at this point, we're back to the last lesson, i.e. we can cancel. We can say, well, 2 divided by 2 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1, and all I have left is 5 halves. Now that works because of the way that you multiply fractions together. You multiply fractions together by multiplying their numerators and multiplying their denominators. Okay? But the key was to have it all in factored form. So take a look at letter B. This looks like an absolute beast, but watch how easy this is going to be. The numerator I can factor in the first fraction by using the difference of perfect squares, x minus 2 times x plus 2. The denominator of that first fraction I would factor by using a little bit of trinomial guess and check, and I'd have something like that. Now, the numerator in this fraction, I'll factor using a GCF. I'll factor out a 3x, and I'd be left with x plus 5. And in the denominator, I can factor out a 2x, and I would be left with a 3x. Ooh, no, I can factor out more than a 2x. That was a mistake. Yeah, let's get the greatest common factor out. Let's factor out a 6x, and that'll leave me with an x minus 2. Now, everything is factored right now. I want you to really realize that what we've got is just a bunch of product. Something times something times something times something, something times something times something times something. So now you can cancel away. You can say x plus 2, let's do this. X plus 2 divided by x plus 2 is 1. I'm going to go some more. Then I can have x minus 2 divided by x minus 2 is 1. Keep going. I can now say that x divided by x is 1. That's okay. That's 3 times x. That's 6 times x. It's factored. Now, I can't do anything with that x plus 5 because the only thing that would cancel an x plus 5 is an x plus 5. The only thing that would cancel an x minus 3 is an x minus 3. There is the little bit of business left here with this 3/6. Obviously, I can cancel a 3 into a 6, and be left with 2. So let's see what we have left. After all that canceling, in the numerator, I have x plus 5, and in the denominator, I have 2 times x minus 3. That is generally an acceptable way to leave the answer. I know that seems strange because it seems like we should distribute the 2. And you could. There's nothing wrong about this answer. That's also quite good. But both of those answers are acceptable. All right. So we're just extending the idea of cross-canceling to more complicated fractions that involve variables. Pause the video now. Think about what we did before we move on. Okay, let's clear out the text. Now, just like before, the key in these problems is to factor first and then cancel. But in letter A and B in exercise 2, everything has already been factored. I want you to really think about this. Everything has already been factored because everything's in monomial form. Now, that being said, how you decide to cancel and when you decide to cancel is up to you. Let's take a look at letter A. All right. For instance, let's take a look at the 8 and the 5. Don't forget that you can always simplify within a fraction as well as simplify by cross-canceling. There's no way to simplify the 8 and the 5, but I could divide out a common 2 from the 8 and the 6 and be left with a 4 and a 3. I could also cancel out a common 5 between the 10 and the 5 and be left with a 2. I can now cancel 3 y's here with 3 y's there and be left with a y to the 4th, and 2x's here and 2x's here, leaving me with an x to the 1st. There is nothing left for me to cancel. Now I have to be careful. I want to multiply this 4 by this 2. That's going to give me 8. That 4 is just the exponent on that y, so that's going to be 8y to the 4th. And here I've got this 3 and this x to the 1st. And that's my final answer. 8y to the 4th divided by 3x to the 1st. Now letter B is a little bit more challenging, but I want to see if you can do it on your own. So pause the video now and see if you can correctly simplify that product. All right, let's go through it. Now again, there's a ton of simplifying here, both within fractions and across fractions. It doesn't matter the order in which you simplify. So for instance, I could take this 6 and this 4 and I could reduce that down to 3/2. All right. I could take then this 3 and this 9 and reduce that so there's just a 3 down here. I can take this 2 and reduce it into the 10 and be left with a 5 up here. And that's all I can do with all the just sort of normal numbers, if you will. All right. Now let me simplify within this fraction. I've got x squared and x to the 5th, leaving me with an x cubed down here. Y squared, y cubed, leaving me with a y to the 1st up here. Here, also let's cancel within fractions. I can cancel an x to the 1st and x to the 5th, leaving me with an x to the 4th down here. A y to the 2nd and a y to the 7th cancel, leaving me with a y to the 5th down here. Now all I've done there is I've only simplified within the fractions. Now let me do a little bit of cross-canceling. I've got a y to the 1st up here, and that can cancel with a y to the 5th down here, giving me a y to the 4th. I've got an x to the 3rd here and an x to the 4th here, but those don't cancel because they're both in the denominator. In fact, there is nothing left in the numerator that will cancel anything in the denominator. The only thing that's left in the numerator is this 5. What's left in the denominator? Well, the only numerical part is that 3. Then we have an x to the 3rd and an x to the 4th, which when multiplied gives me an x to the 7th. And then that y to the 4th just hangs out. And there's my final answer. Let me just make sure that's right. Yep, absolutely. So we can cancel within fractions and we can cross-cancel as long as we've got products. Wait until we have sums and differences. Then it gets a lot more difficult. All right, pause the video now. Think about what we just did. Okay, I'm going to clear out the text. Now, in A and B, what we had expressions that were all monomials, so technically they were already factored. Maybe not completely factored, but they were factored. In letters C and D, now we have to do the factoring, right? Because these things have not been factored. Let's do it together, okay? Letter C, let's take a look at this first fraction. Let's factor the numerator. That's going to be 2x times x plus 6, just a little GCF. The denominator is also a GCF. It's just 4 and x plus 2. All right. Now, by the way, I didn't want to do that. There's no equals here. Before we move on, I really want you to be aware that in the numerator, there's 3 factors, 2x and x plus 6. I put little dots between them. And in the denominator, there's just 2 factors, 4 and x plus 2. All right. Here, the numerator will be factored by a little trinomial guess and check. What will that be? X minus 6 and x plus 2. Always check. And denominator, x minus 6, x plus 6. All right, let's start to cancel. And let's do some obvious ones. So for instance, within this fraction, an x minus 6 cancels an x minus 6. No problem. Then across these fractions, an x plus 6 cancels with an x plus 6, and an x minus 2 cancels with an x minus 2. Now, a lot of people at this point will stop and they'll go, all right, great, I've got 2x divided by 4. Right, I got this. But the problem is 2/4 can still be simplified, right? Because I can cancel a 2 here and a 2 here, and I'm left with a final answer of x divided by 2. And that's it. Nothing more than that. All right, pause the video now, and you take a try at letter D. It's definitely a little bit more complicated than the one we just did, but just barely. Just watch yourself. All right, let's go through letter D. Again, we're going to look to factor all over the place. So in the first fraction's numerator, we have the difference of perfect squares, 3 minus x times 3 plus x, not x minus 3 times x plus 3. In the denominator, this is interesting because we've got an x cubed and an x squared, so we can actually factor 2x squared out of both of those, leaving me with an x minus 3 times. In the numerator here, I can factor a 4x out of both this and this, leaving me with x minus 1. And in the denominator, I factor that using a little guess and check. I believe it's x plus 3 and x minus 1. All right, let's do some canceling. Again, there's some things that are very obvious, like within this fraction, x minus 1 cancels x minus 1. All right. There are some things that are less obvious, like x plus 3 cancels 3 plus x. And then, maybe the trickiest part is that x minus 3 and 3 minus x cancel, but they leave you with a negative 1. As a piece of advice, I would always leave the negative 1 when that cancellation occurs in the numerator, not the denominator. All right, now we've really canceled all the complex factors. The things that are a little bit easier, but sometimes easy is not great, are things like 2 going into 4 2 times, and x to the first going into x to the second, leaving me with an x to the first. At that point, I've really canceled everything I can cancel. I look across the numerator. The only thing left is a negative 1 times 2, which is negative 2. And in denominator, the only thing that's left is actually this x to the first. So believe it or not, all of that reduces down to negative 2 divided by x. So that's it. Pause the video now and write down anything you need to. Okay, let's clear out the text. So simplifying products aren't too bad. Now let's simplify some quotients or division problems. Now, really, these are no more complicated than the last set of problems. They just involve one more step. And they involve one more step, let me remind you, because when we divide fractions, when we do 3/2 divided by, let's say, 7/4, We change that into an equivalent multiplication problem by multiplying by the reciprocal of the second fraction. A lot of math teachers will use some kind of mnemonic like stay, change, change, or stay, change, flip, right? Something like that. Stay, change, flip, something. The idea is that, and it's very simple. Dividing by 2 is the same as multiplying by 1/2. Dividing by 1/3 is the same as multiplying by 3, right? So the only extra step that division problems throw in is this initial step where we've got to change this into this. And it's annoying simply because we have to write a little bit more, right? We have to remember to do it. But once we've done that, then we're right back to what we were doing before. We can cancel a 5 into a 15, leaving us with a 3. We can cancel an x squared with an x to the 8th, leaving us with an x to the 6th. We can cancel y to the 5th with y to the 7th, leaving me with a y to the 2nd. Once we've done that, we've canceled everything we can cancel. What do we have left? We have 3 times 2, which is 6, times y squared, and in the denominator, we just have that x to the 6th. All right, so the only additional part of division is changing it to multiplication. And I'm sorry about that, but it is something that you've seen before in middle school. Stay, change, stay, change, flip, however you want to put it. I hope that you understand it and you had time back in middle school to kind of internalize why dividing by the fraction is the same as multiplying by its reciprocal. But that's not really for us to investigate now. All right? Why don't you pause the video and try letter B? Okay, let's go through it. I'm going to make sure to shift my own sheet over so that I know what the proper answer is. All right, it is really important in this problem that I start off like this. I must change it to multiplication first, right? Once I do that, all bets are off. We can cancel, we can do all sorts of stuff within the fraction, across the fractions. So I think I'll divide out a common 10 from these two, be left with 3/2. I think I'll divide out a common 8 here, and I'll be left with 1/3. I think here 1x will cancel with 1x, leaves me with an x squared. Here 2y's will cancel 2y's, leaving me with a y to the 4th. I take a final look, I don't see anything. So 3 times y to the 4th times 1 is 3y to the 4th, and in the denominator, 3 times 2 times x squared would give me 6x squared. Now, it's always a good idea, once you've done all of that, to look one last time. Is there anything I missed? And there was. You see, right here, I could have actually canceled these 3's. It would have saved me a little bit of time. But since I didn't, I now have to do it at this stage. That's supposed to be a 4. Doesn't really look like a 4. And I have to be left with y to the 4th divided by 2x squared. Yeah, that's still right. All right, pause the video now and write down anything you need to. Okay, let's clear out that text. Now, just like before, now we go to ones where the numerators and denominators are not monomials. Okay, and like before, my first step will be to stay, change, or stay, change, flip, or however you want to put it. So I'm going to change that division into a multiplication by the reciprocal. But then we're back to what we did in the last problem. I'm going to factor this numerator using trinomial guess and check. Factor the denominator. We've got a little bit of GCF. Factor this numerator. Again, some GCF work. And factor this denominator. And there we have it. All right, cancel away. Maybe go in red to cancel. I like the red for canceling. X minus 2 cancels x minus 2. X plus 4 cancels x plus 4. 2 goes into 8 4 times. And I think I'm done. My final answer has an x plus 5 in the numerator and a 4 times x minus 4 in the denominator. That's an okay way to leave your answer, but depending on the context, you may also want to distribute the 4. Take a look. Yep, that's it. All right, pause the video now and you work on letter D. Okay, let's go through it. Keep looking for those 3 major types of factoring. Factoring by grouping could also come up in this. It's less likely, but it could. But the 3 major types of factoring, GCF, difference of perfect squares, trinomial, guess, and check. So, in this problem, the first numerator, sorry, I just broke my cardinal rule. The first thing that I want to do is rewrite the problem, give myself a little bit of extra room, rewrite the problem as a multiplication problem. So I'll leave that first fraction alone. I'll change to multiplying and multiply by the reciprocal. All right, now we're good to go. So the numerator of that first fraction, it's the difference of perfect squares, so we can factor it as 3x plus 1 times 3x minus 1. Probably the most challenging part of this problem is factoring this thing. It's going to be 3x and x. There's going to be a 2 there and a 1 there. 6x, 1x is 7x. Great. Here again, trinomial factoring, x minus 7 times x plus 2. And then GCF like that. Go into red to cancel. Easy stuff. 3x plus 1 cancels 3x plus 1. X plus 2 cancels x plus 2. Here comes the tricky part of the problem. 3x minus 1 and 1 minus 3x cancel to be negative 1. Don't lose that. And that's it. So my final answer is that negative 1 times x minus 7, all divided by 5, or negative x plus 7 divided by 5. Okay, division. Not so bad. Pause the video now. Write down anything you need to. Okay, let me clear it out. All right, last problem of the lesson, just a little bit of a multiple choice problem. Why don't you pause the video now and try to take care of this. Okay, let's go through it. This one's actually on the easier side of the ones that we've been doing, but we have to make sure that we get it right. It says when x squared minus 25 divided by 3x is divided by x plus 5 divided by 9x, the result is blah. So we have to make sure that we have the order correct. Otherwise, that is an easy error to anticipate. But we'll change that into a multiplication problem. Only one thing I have to factor, which is that numerator, x minus 5 times x plus 5. And now it's time to cancel. All right, easy. X plus 5, x plus 5, x and x, 3 and 9. Notice how I treat those completely separately. And we have it. In fact, I have a 3 and an x minus 5, which means I've got 3x minus 15. All right. Pause the video now, write down anything you have to, then we'll wrap it up. Okay. Clearing it out. So in today's lesson, we took what we knew in terms of multiplying and dividing numerical fractions, and we applied it to algebraic fractions, to rational expressions. Still, at the end of the day, it pretty much boiled down to a two-step process. Step 1, factor. Step 2, cancel. With division, we had to throw in an extra step where we changed the division problem into a multiplication problem, but besides that, it was literally almost identical. All right, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.